Okay, so what we were discussing yesterday, this set bounded. That means we can produce two numbers, right, such that the elements are lies in between. Every element of this set lies in between minus 26 by 2 plus 26 by 2. So that is what we discussed last time, and basically what we discussed yesterday: upper bound, lower bound, maximum element, minimum element, bounded above set, bounded below set, and bounded set. Right. So this is what we discussed last time. Right. So uh, so what we discussed last time: maximum element of a set. Right. So we discussed maximum element, and then exercise you can work out is prove that maximum element of a set is unique if it exists. So if maximum element of a set exists, then it is unique. So can you prove this? So how will you check this? The maximum element of a set is unique if maximum element exists. Do you understand the question? Do you understand the question?
Yes.
So how will you verify that if maximum element exists, then it is unique? So
First, we'll consider a set with two maximum elements. Then we'll hold cases. First case would be one is greater than other. Then the second would not be the maximum because it is smaller than an element of the set. And the second case would also be the same, that second is greater than the first one. And third case will be equal. So it's satisfied only when it is equal.
right, very good. So let A be a non-empty set, right? Suppose U and V are two maximum elements of A, right? Suppose U and V are two maximum elements of A. Therefore, by definition of maximum element, therefore U and V are members of A, right? Because maximum element is always a member of set. So, and when we say that there are two maximum elements, two distinct maximum elements, or two elements are maximum elements, and x is less than or equal to U and x is less than or equal to V for every element in A, right? So every element is less than or equal to maximum element and maximum element. So if every element of set A is less than or equal to U, and we know that U is member of A, therefore V is less than or equal to U. And when we say that every member of set is less than or equal to V, and U is a member of A, therefore U is also less than or equal to V. What is the conclusion? Right? So V is less than or equal to U, and U is less than or equal to V. This is possible only if U is equal to V. Correct? And therefore, uh, you cannot have distinct maximum elements. If you say that the maximum element exists and there are two, then they are actually same. Thus, maximum element is unique. So cannot have two. So similarly, you can now prove that we discuss minimum element. Right. So prove that minimum element of a set is unique if it exists. So that you can check. So now what we want to learn is very important axiom of real numbers, right? That is CLUB and GLB axioms. CLUB and GLB axioms of real numbers, and which are axioms means, of course, these are the basic assumptions, rules in the defining structure of real numbers, and this plays very important role in analysis, right? So before going to this, we'll make some definitions. So what is LUB and what is GLB? Like you studied in school, yeah, GCD and LCM, right? GCD means greatest common divisor, LCM means least common multiple. Like so, what is LUB and what is GLB? Okay, so we'll try to understand something before this. So if you look at set A, 1, 2, 3, 4. So what is upper bound? What are upper bounds?
4, 5.
Of A, right? 4, 4.001, right? 5, right? So there are many upper bounds. But if you look at 4, 4 is a special, right? Because 5 is not special. 5 is upper bound, but 4.5 is also upper bound. 4.7 is also upper bound. 4.001 is also upper bound. So there is nothing about nothing special about 5, but there is something special about 4. So what is the special about 4?
It is maximum element also.
Yeah, okay, but
So it is the
if
lowest
Yeah.
upper.
so
It's
3.9
included in
is
this.
3.9 3.9 is not upper bound, right? So if you go below 4, if I take any number u less than 4, then u is not upper bound, right? This is important point. If you take any number smaller than 4, then that number cannot be upper bound. Is it clear? Is this correct what I am saying?
Yes.
Yes, so 4 is lowest upper bound.
So 4 is the smallest among all
Lowest
upper
upper
bounds, right? So 4 is the least among all upper bounds of set A, right? It is the least among all upper bounds. You should look at all the possible upper bounds of set A, then 4 is the least. You cannot go below 4. If you try to go below 4, the number becomes not upper bound, right? So let us see another example. Set B, x such that 0 less than x less than 1. So if you look at u is equal to 1, right, and 1.001, 1.5 to, you choose all the possible numbers, so 0 and 1. So every number greater than 1 is upper bound, so all these numbers are of set B, right? This is correct. That means,
Yes.
right, that means every u which is greater equal 1 is an upper bound of set B. Every u, whatever you select, u which is greater equal 1, either 1 or greater than 1, every such number is an upper bound. Now, this is the first observation. What is the second observation? If I take W,
One is LUB.
right, so if you select W is equal to some number 0.937, then is not upper bound of B. That means if you select any number W smaller than 1, right, that is if W is less than 1, whatever it may be 0.9978 or it is very close to 1, right? Once it is less than 1, what happens? When I say that W is less than 1 means what? Here it is 1 and it is W. So W is less than 1 means what? There is some space, some gap between W and 1. That means 1 minus W is positive, right? And 1 minus W is this length. And in that length there are members of set B which are greater than W, right? So X is greater than W, so and X is member of set. That means how you, so W cannot be upper bound because some members of set are greater than W, right? That we can immediately see from this figure. So if W is less than 1, then W is not an upper bound of upper bound of B. So if you choose any W smaller than 1, then it is not an upper bound of. And what is the conclusion from this? Therefore, 1 is least among all upper bounds of B. So it is a list because first of all 1 is upper bound, right? And no number greater than, so all other numbers are greater than 1 are upper bound and no number smaller than 1 is upper bound, so 1 is the least. So this is just simple observation from this. So what is one more observation for this set? Third observation, 0 is lower bound
Yes, sir.
of B, right? 0 is a lower bound of this
Yes.
set 0, right? And you choose any V less than or equal to 0, right? So my set B is 0 to 1, and what I observe here, any number greater equal 1 is upper bound, and if you choose any number W less than 1, it is not upper bound, so 1 is the least among all upper bounds, and 0 is a lower bound because all members of set are greater equal 0, so 0 is a lower bound, and every member less than W is also lower bound. Any V less than 0 is also lower bound, correct? This is next observation, correct? So any V less than or equal to 0 is also lower bound of V. You choose any number smaller than 0. If I take V smaller than 0, then also all members are greater equal V, so V is lower bound. And next observation, if I choose any Z greater than 0, So if z is greater than 0, then what happens? Do you understand? If I take 0 is here and z is here and z is greater than 0, then there is some gap between z and 0. So what about such numbers which are in between 0 and z? Then there is x in set B such that x is less than z. So what is the conclusion of this?
Z is not a lower bound of set B.
So that it is not lower bound of B. That means what we observe ki any number less equal 0 is a lower bound, and more or 0 is also lower bound, and no number greater than 0 is lower bound. What is the conclusion? Why 0 is a special now?
0 is greatest upper bound.
Greatest.
Lower bound. Greatest lower bound.
Greatest lower bound.
0 is greatest. Right? 0 is greatest among all of set B, because -1 is lower bound, -1.5 is lower bound. So there are many lower bounds. 0 is a lower bound, but if you go slightly right side to 0, then immediately we can see that there are members of set which are not greater than z. So any number greater than 0 cannot be lower bound. So 0 is the greatest among all lower bounds. Alright, so if you understand this example, why 1 is special and why 0 is special in this case. In previous example, this 4 element set, 1 is special and 4 is special, right? Because 1 is a lower bound and 1 is greatest among all lower bounds. So here 0 and 1 are special. So now we can define. So we are now can make definition. So least upper bound. Right? Least upper bound or LUV. Least upper bound or LUV of a set. So what is the definition? What is the definition of LUV or least upper bound? What should be the definition of least upper bound? So let A be a non of real numbers, right? Remember, we are talking about subsets of real numbers. So A be a non-empty subset of real numbers, and why we are taking non-empty, that we'll discuss. So real number U is said to be least upper bound of A if following conditions are satisfied. What are the conditions? Some number is least upper bound of set A. For example, in previous one was least upper bound of interval 0. So what are the conditions you should satisfy? Use just real number, but when you believe that it is a least upper bound. So what is the first condition? U is an upper bound of A. First of all, it should be upper bound, right? That is, what does it mean? X is less than or equal to U for every X belongs to A. What is the meaning of U is an upper bound? So every element of set is less than or equal to U, right? This is the first condition. Now second condition, U is the least, right? So here why I am using the, right? Why I am using word the?
So because it's unique.
Unique.
Because we in the previous discussion, minimum element is unique, right? It is least. Least means what? Minimum element. Do you remember this? Minimum element or least element. Is it correct? Is this clear?
Yes, sir.
Right. So
Yes.
when I am talking about least element, that means I am talking about minimum element, and we have already discussed that the minimum element is unique. So the least upper bound, right? So what is the least upper bound? Least upper bound is upper bound basically, and then it is the least among all other upper bounds of A. It is the least among all upper bounds. That is, what does it mean? That is, if V is any other upper bound of A, then what you can say? So U is upper bound, but U is the least
U,
upper bound, and V is
U is
also
less
upper
than
bound,
V.
right? So then U is less than or equal to V, right? Because there are many upper bounds, but what is the speciality of U? U is the least among all upper bounds, right? If you choose any other upper bound, for example, in previous case, interval 0, 1, 2 is also upper bound, 3 is also upper bound, 1.5 is also upper bound, but 1 is less than or equal to all other upper bounds. That is what the 1 is special, right? So that is what the meaning of it is least among all upper bounds, all other upper bounds.
Sir,
Fine. So this is the definition. Yes.
sir, if the like maximum element is not included in the set, like we took the set 0 less than x less than 1, so we can't use the here, no, in second point.
Oh, I am not. I am not saying that U is a member of set. Do you understand?
Yes, sir, but that uniqueness property we applied here, no? You say that U is the least among all other.
Yeah.
So it isn't.
Your doubt is correct. What I will explain now. So consider same example. Set B is equal to X such that. Okay. Now I am going to construct a set U is equal to set of all upper bounds of B. Now, can you tell me what is my set U? Set of all upper bounds of U of B. This is my set U. This is
Greater than equal to.
Greater than equal to 1.
right. So all those y's which are greater equal 1. Anything greater equal 1 is upper bound. So what is my set? 1 to infinity. Right?
Yes, sir.
What is the least element of
1.
U? What is the least element of U?
1.
1.
1. And it is a member of U, no doubt,
Yes.
right? And it is unique. So least element of U is least upper bound of V. Right? And why it is unique? Why it is the? Because it is a least element and it is a member of some set. Now your doubt is clear?
Yes.
Right. So you should observe such kind of things. We are looking at the set of all upper bounds and which is the list, and list definitely exists, so it is unique. We'll see. You will prove it is unique. So let me say that what we can say it is theorem or exercise or theorem. So let is a non-empty set, right? Prove that list upper bound of A is unique if it exists. List upper bound of set is unique if it exists. How will you prove this? Can you prove this? Proof is not very difficult. Suppose list upper bound of A exists. Exists. Suppose list upper bound exists. Let U and V be two list upper bounds of A. Suppose these are two list upper bounds, right? Then what is the first observation? U and V are upper bounds. Of A, right? Am I right? First
Yes.
observation is U and V are upper bounds. What is second observation? Since U is least upper bound and V is right. Since U is least upper bound and V is upper bound of A, what is the relation between U and V?
U less than equal to V.
U is less than or equal to V, because it is very clear that V is upper bound and U is least upper bound, so U is less equal V by definition of. What is one more thing? Since V is least upper bound and U is upper bound, what you can say?
V is less equal to U.
Right, so V is less equal to U. And what is the conclusion? U is equal
U
to
is equal to V.
right. Therefore, you cannot have two distinct
LUB.
LUB, right? If
LUB.
LUB exists, then it is unique. Right. So this is clear now, and that's why I use the word here, the least upper bound. The least upper bound. Okay, so note. So least upper bound of a set is called as supremum of set. So we denote supremum of set A as or CLUB of A. Right, so supremum S sup, or what is the meaning of this? Supremum of A or A of A. So therefore, if my set A is equal to elements between 0 and 1, then from previous discussion, what is supremum of A? Supremum of A is 1. Right, supremum of A is equal to 1. So any confusion in this definition?
No, sir.
Right, so very good. Supremum is 1. So if my set is equal to 1, 2, 3, 4, 5, right? Then what is supremum of this set? What is supremum?
5.
5, right? Now if my set is B, X such that less than or equal to 1, then what is supremum of A? So set in this previous case
1.
1, right? Still supremum is 1, even 1 is included. So in right here, one observation, if I look at these two particular cases, observe here that 5 is maximum element and supremum, right, of set A. What is second observation? 1 is maximum element of B. Is it true? 1 is maximum element of B. Is it true?
Yes, sir.
And 1 is supremum also. Supremum of B. Correct? But if you look at third example, all those numbers, right? Then what is supremum?
1.
So supremum of C is 1, but 1 is not maximum element,
Yes.
but 1 is not maximum element of C. In fact, maximum element does not exist. In fact, maximum element of C does not exist. Right, and therefore what general statement I should make? What general statement I should make? If maximum element of a set exists, then it is supremum. Is it true? Is this statement true?
Yes, sir.
So if maximum element exists, then of course it is a member of set and all other members are less equal and it is least among all upper bounds. So it is upper bound and it is least. So it is supremum, no doubt. Is converse true?
No, sir.
Converse is not, right? So you should write down the proof of this. So this is a very simple theorem. and you should write down the proof now. Suppose you take A as a non-empty set. Suppose its maximum element exists. Suppose M is a maximum element. Then prove that it is upper bound and it is least among all upper bounds. So that you should prove. And why converse is not true? So if you want to prove that some statement is not true, then to right, you should give some counter example. Right? How will you prove the converse is not true? We understand logically if some statement is false, then how will you prove some statement is false? How will you prove? You understand logically. Suppose I say that suppose I have a box containing mangoes, and my statement is all mangoes in this box are sweet. Right, so all mangoes are sweet. Suppose this statement is false. How will you prove that statement is false? Right, I am making a statement all mangoes in this box are sweet, and somebody say that his statement is false. How will you prove that my statement is false?
I'll find one mango which is not ripe.
Right, very good. So when I am saying all, then one example, one mango is sufficient. Right, so you can produce one mango, just take away one mango, and that particular mango is not sweet. If you can show this, then that is sufficient, right? One mango is sufficient to say that the statement is false. So this is a logical way, right? So if I say that converse, what is a converse statement? If supremum exists, then maximum element exists. This will be the converse. And when that statement is false, you can give me one counter example where supremum exists but maximum element does not exist. And what is the counter example? This set interval 0 1. Set C in this case. Its supremum exists but maximum element does not exist. So the statement is false. The converse is not true. So think about it. Is it clear? Is this clear?
Yes, sir.
Yes, sir.
Right. Okay, so now we understood lower bound, we understood greatest lower bound, right? Which is the greatest among lower bound from previous discussion. So I want to make another statement. So let A be a non-empty subset of R, non-empty subset of R. A real number V is said to be greatest lower bound of A if so A is a non-empty set and V is some number V, and when we say that it is the greatest lower bound of A if two conditions are satisfied. What are these two conditions? Analogous to our previous definition.
V is lower bound
Basically it should be lower bound. V is
and V is greatest among all lower bounds.
lower bound of A. That is V is less than or equal to X for all members of A. All members of set are greater or equal. V means V is a lower bound and V is greatest among all other lower bounds. of A. That is, if W is any other lower bound of A, then what is the relation between V and W?
V is greater than W.
Right, so W is less than or equal to V because V is the greatest, right, among all lower bounds. V is greatest among all lower bounds. So if you choose any other lower bound, it is certainly less equal V. V is the greatest among. So greatest lower bound of set A is denoted by is called as, first of all we can say that greatest lower bound of A is called as
Infimum.
right, called as infimum of A and is denoted by greatest lower bound of A is infimum of E. So again, if we see this same example, x such that 0 less than x less than 1, and if I look at set L is equal to y belongs to R such that y is lower bound of A. So this is a collection of all lower bounds of A. And now you can tell me what is this set Y? What is this set? What are all lower bounds? 0 less equals 0 because 0 is a lower bound and any number less than 0 is lower bound. So what is the collection of all lower bounds of this set? Minus infinity to
0.
0, and I should include 0 also because 0 is there. 0 is a lower bound. And what is the largest element or greatest element?
0.
Greatest element of L is 0, which is greatest among all lower bounds of A, which is infimum of A. Right. This is what the simple observation you can. So, and therefore it is unique, right? So prove that. Infimum of a set is unique if it exists. Right. So by same logic, you should prove it. Right. Analogously, you can write down the proof. If infimum exists, it is unique. Right. One more thing. If you look at this set 1, 2, 3, 4, then what is minimum element? Or least element of A is 1, right? Is it correct?
Yes, sir.
Minimum element of this set is 1, and what is infimum of this set?
1.
1, right? That is easy to observe for this particular set, and therefore what is my general statement? If least or minimum of a set exists, then it is the infimum of it, infimum of the set. Converse is not true. So converse is not true. So that means if infimum exists, then minimum element may not exist. So this is example interval 0, 1, infimum is 0, but minimum element does not exist. So that is something you should write down the proof. Right, so proof is exercise. You should write down the proof. Then only you can understand this idea. So you should not expect, yeah, you should write down each and everything and then you will just observe it. That is not the right way to learn mathematics. Right, so you have to apply these definitions and think over it. That will be helpful to you. Now, one obvious question that must be in your mind, and what is that obvious question or basic fundamental question that you should ask, right? Why I am saying non-empty? Right? Right, so why we are considering non-empty set?
An empty set is unbounded. It cannot be bounded by two elements.
Why? Why empty set is unbounded? There is nothing. What is the problem? If you look at
Because
natural numbers are unbounded because if you take any number, you can find a bigger number than that.
because we cannot find two real numbers with no distance between them.
So suppose A is empty set, right? Empty set. Then 3 is an upper bound of empty set. Is this statement true? Is this statement true? Is this statement true or false?
Yes.
True.
False, because there is no element in A.
Okay, so my next question is a question or what? Note. U is upper bound of A. What is the definition of U is upper bound of A? If U is upper bound of set A is, what is the definition? For each element in A, X is less than or equal to U. Is this true? What I am saying?
Yes, sir.
Yes, sir.
Okay, what is a negation? What is a negation?
X is greater than U.
What is the negative statement of this? Negative statement of first.
There exists an X belonging to A such that U is less than X.
U is not an upper bound of A if the second condition fails. So this fails means what? Every X is less than or equal to U fails means what?
There exists X belonging to A, U is
So
less than X.
there is at least one member X in A such that for which that less equal U fails, right? X is greater than U. Is it logically correct? Is it logically correct? Right?
Yes, sir.
This is all about logic. It is not very difficult thing, but the logic should be clear. So when I say U is a list, U is upper bound. U is upper bound means all members are less equal U, and U is not upper bound means what? Not all members less equal U. That means when all members means what? Like all mangoes are sweet. What is the negation? Not all mangoes are sweet. That means at least one mango is not sweet. Similarly, what is the negation? Not all elements less equal U means what? At least one element is greater than U. Correct? Okay. This is fine. Now, when you say that if 3 is not upper bound of empty set, if when we believe that 3 is not upper bound of empty set, if same thing I want to state here. 3 is not upper bound of this set, whatever this set, forget about empty set, whatever. 3 is not upper bound of this set if what? If what I should say?
3 is less than X.
If there exists member of set such that X is greater than 3. When we believe that 3 is not upper bound of empty set, if we can produce one member in the set which is greater than 3, is it possible? Now my question is, can you produce at least one member X in empty set such that X is greater than 3? Can you produce?
No.
No. So there is no counter example to this. So when we believe that U is not upper bound, if you can produce one counter, right? Can you produce one counter? Can you counter the statement that U is upper bound? Can you produce a counter example or an element which for which this condition of upper bound fails? Right? So if you cannot produce such element at all, then you have to believe that U is upper bound. Can you produce? Am I right? Is it clear or not?
Yes, sir.
So you cannot produce a member of this empty set because there is nothing which is greater than 3. And so what we have to accept? What you should accept?
3 is upper bound.
So we accept that 3 is an upper bound of empty set. See, this is a very deep logical philosophical fact that you have to accept, right? So if you do not have a counter example, then you believe that statement. That always happening in day-to-day life, right? You take any thing in the universe or in day-to-day life, unless you have a counter example, you have to accept that statement. right? So there are many such situations where we use the same kind of logic, unless you produce a counter, right? Fine. So, and therefore 3 is upper bound. Hence, 5 is upper bound.
Yes, sir.
Is upper bound. 20 is upper bound. Minus is upper bound. Am I right?
Yes, sir.
So what is the conclusion?
All real numbers are upper bound.
Every real number is an upper bound of empty set, and therefore what is least upper bound? What is least upper bound?
Minus infinity.
Which is not real number. Does it exist in real world? We are talking about real number. We don't know where is minus infinity. We cannot reach to minus infinity, which is not in our universe. So what we should say? What is the least real number does not exist? Does not exist. That means it is not in our world. It is not in the real numbers. Correct?
Yes, sir.
And therefore least upper bound or supremum of empty set does not exist. Similarly, infimum of empty, because every real number is a infimum, and the greatest every real number is lower bound, and so greatest lower bound does not exist. So, and therefore for empty set supremum infimum does not exist. So for empty set it doesn't make sense talking about supremum infimum. That's why we are avoiding empty sets. Is it clear now?
Sir, but how can we have a set for which upper bound is less than a lower bound?
There is no such set at all. Okay, there is no such set that upper bound is strictly less than lower bound. Right? If I take A is equal to single element set, what is upper bound? 1. What is lower bound? 1. In this case, upper bound and lower bounds are equal. Correct?
Yes, sir. For the set 5 talking about for empty set.
That's why the we are avoiding empty set, because for empty set many rules fails. Which rules fails? So if A is non-empty set, then prove that. What we should prove? Infimum of A is less than or equal to supremum of A. Right. So this is whatever theory, whatever properties, whatever rules we are going to discuss for non-empty set, because for empty set things are very irregular, right? Because every real number is upper bound, and for non-empty set what happens? Upper bound is always greater equal lower bound, right? Is it clear now?
Yes, sir.
Right. So very unusual things happens with empty set. So empty set is not important for us. Okay. So think about it and try to work out exercises what I mentioned in this session. Right. So work out all those exercises. That will be very helpful to understand the next sessions. And I